Side effects include nausea, diarrhea, and vomiting, which can cause dehydration and may cause kidney problems.
I can do diabetes differently with Mounjaro.
Pay as little as $25 per month. Ask your doctor about Mounjaro.
You can also create network diagrams that combine layer 1, layer 2, and layer 3 views of the network. Layer 1 would be the physical layer, layer 2 would be the data link layer, and layer 3 would be your network layer. Here's an example of a network diagram that includes a number of switches, routers, and end stations, and we have labels here for layer 1, layer 2, and layer 3. We can start with the layer 1 connection, which shows the physical interfaces for the switches and the routers where all of these wires are connecting and providing this connectivity. We can overlay on top of that a layer 2 perspective, which now includes MAC addresses for all of these different components. And if you wanted to include IP addresses, we can overlay the layer 3 addresses so that you know exactly what IP address is associated with which MAC address, which is also associated with each physical address. Another important part of documentation is a need to track your assets. This means that we need to put tags or labels on every asset that we're bringing into the organization. This would be laptops, desktops, routers, firewalls, switches, and anything else that we're buying and installing into our network. Once we have all of these devices tagged, we can use that tag when we're referring back to a trouble ticket or some type of problem. For example, we could say that a router in the data center that's labeled with number 42 is the one that's causing this particular problem. We can also use these tags for financial purposes. We may need to track these devices over time to be able to track their depreciation. Or you may need to reference the asset tag to know when the device was purchased, which would also tell you if that device was currently still under warranty. These asset tags are usually very visible so that you can find them when you're on the phone with someone in the support team. There might be a barcode or RFID associated with this, and there might be additional information. If a third party runs across this device, they'll know exactly who owns that particular piece of equipment. The asset tag that's connected to the device, the components within that device, and then the user who is using that particular device may all be combined within one single asset database. This becomes a centralized database that can be used by the asset support team, by accounting, by folks that are in the finance department, and anyone else who may need access to this data. If we need to know the physical location of a device, we can look at our asset database and see what user has been assigned to this particular component. If we then know the user's location, then we also know the location of this particular device. As we've also mentioned, we may want to use this also for warranty tracking to be able to understand when a device was purchased and what the status is of that particular warranty. And if we're tracking the number of devices, we can also track the software that's running on those devices. This can be very useful if we need to determine how many licenses we need to purchase for our organization. We can determine very quickly how many of those units we own by referencing back our asset database. Another important piece of documentation relates to the ongoing use of IP addresses in our organization. We would commonly track these by using an IP address management or IPAM solution. This is something that can provide us with a way to plan, track, and configure the DHCP and IP address schemes that we are using throughout our company. Using IP address management, we can document what users may be using what IP addresses. Since we often use dynamic IP addressing, it's useful to be able to map a user with a specific IP address during a particular date and time. This might also give us the ability to identify any problems or shortages that we might have with our IP addressing configurations. And based on this information, we might need to modify IP address ranges or add additional IP addresses to our DHCP infrastructure. This gives us a way to manage all of our IPv4 and IPv6 addressing throughout our organization, all from one central console. Here's a console from an IP address manager showing different subnet details, statistics about the IP addresses that we're currently using, changelog entries, warning and error logs, and other details that can help us manage our IP address configuration. If you're working with a service provider, and most organizations are, you'll need some way to verify that you're getting the proper level of service. This is often done contractually with a service level agreement, or SLA. This defines the minimum level of service required for this contract that you have with this third-party organization. For example, if you're contracting with a wide area network provider or an internet provider, you may have an expectation that you'll be up and running 99.99% of the time. And you might want to have that level of service documented as part of this SLA. You can use this for any type of service level. For example, you might have an SLA that your organization will have no more than 4 hours of an unscheduled downtime. This means that your service provider will need to have something in place to be able to bring you up and running if you happen to have an outage. They might have a process for quickly dispatching a technician, or they might have equipment that they keep on your location that you can pull out of a box, put it in the rack, and get up and running as quickly as possible. As we're increasing the amount of access points and other wireless infrastructure in our organizations, we need some type of documentation to understand the impact of all of these different wireless components. For that, we will create a site survey. This would allow us to identify all of the access points that we might be using, even if they're access points that we may not be in direct control of. We can at least see the frequencies that are in use and be able to document those as part of the site survey. Once we understand all the frequencies in use, we can then document those and configure our systems to have the minimum level of interference for all of our access points. If you're in a building with a lot of different companies, or you happen to be in a large campus where there are many different buildings owned by different organizations, you may want to perform these site surveys very often to understand exactly what the wireless infrastructure may look like. One common way to document this is with a heat map. You can walk around and use a mobile device to be able to document how the wireless signal may be propagating depending on where you may be standing inside of your building.
What's a threat actor? There are 7, and I can name them. Look, I used to think IT security was just like passwords and maybe locking your screen. Then I started the Dion Security Plus course, and I swear I started seeing everything differently. And I can't even open public Wi-Fi now.
One of the challenges we have when installing new equipment into our data centers and our networks is that eventually this hardware and software will be outdated. We refer to this as end of life, or EOL. This is when the manufacturer of that piece of equipment decides they are no longer going to support that particular product. They may continue to provide security patches and updates, but they are no longer going to provide new versions of software or enhance the features associated with that product. And eventually, the manufacturer of this equipment may decide to no longer produce any type of security updates. When there are no type of updates coming from a product, we refer to that as end of support, or EOS. You won't receive any patches, any updates, any new features, or anything associated with that particular product. When a product moves into end of life, we can put together a plan and a budget for replacing that product over a period of time. But when a product hits end of support, this becomes a significant security concern, especially since we know that we will never receive another security update for that product. These ongoing patches and bug fixes can be very important for maintaining the uptime and availability of these devices, especially when these updates are associated with stability fixes. But these might also be fixes that close security holes, which may be just as important as maintaining the uptime of the device. We often see this with operating systems, where we may receive a service pack every quarter, and we may have to install a large number of updates to these systems when we first install the OS. Many organizations provide monthly updates on a recurring schedule. This means we know exactly when the latest updates are going to arrive, and we can set up our plans for deployment around those update timeframes. And occasionally a manufacturer will introduce an update outside of the scope of that normal monthly update. This is often associated with a security concern, especially when a 0-day or some other type of significant security event occurs. It's not unusual to see updates to operating systems occur constantly across many aspects of that operating system. For example, we can have updates for Windows, Linux, our iOS and Android devices, and anything else that might be running an OS. It's very common to see these monthly updates occur for the operating systems. These might have bug fixes and security patches, but we might also be making changes to the operating system ourselves. We might be modifying user accounts and changing the way that users interact with the operating system. For example, we might increase the minimum password lengths, we might change the complexity of the passwords required for the operating systems, or we might change the way that users are able to access the operating systems, and we might deploy those updates to the operating systems on demand. We might also change the configurations of the built-in firewalls on these devices. These operating systems provide us with a way to limit where a user may visit by IP address or URL, or there might be changes that enhance the security features on that device. And there are constant changes to the embedded anti-malware and antivirus that's included with many of these operating systems. If we're managing a purpose-built appliance or a purpose-built piece of hardware, then we don't usually have access to the operating system that's on that device. And often these devices have their own operating system and configurations. We refer to this software that's running this piece of hardware as the firmware of that device. So if you're working with printers, cable modems, or other devices that have their own embedded operating system, you might be required to update that firmware occasionally to close security holes. This update may be done over the network, or it may require you to visit the device and physically connect to the device to perform the update. We know that we can't use this hardware unless the software in this device is working properly. So it's a good idea to have a plan for upgrading this that would include a way to fall back to a previous version if that newer version runs into a problem. It's often a good idea to save those firmware binaries in a safe place so that later on down the road you wanted to go back to a previous version, you would have access to all of that code. One of the challenges with managing firmware in your printers, your modems, and other devices is that these companies are very good at manufacturing hardware, but they may not be as good at maintaining the firmware that runs in those devices. An example of this would be the Trane ComfortLink 2 thermostats, where you could control the temperature on the thermostat from your phone. There were 3 vulnerabilities presented to Trane in April of 2014, but we didn't receive updates to the firmware until April 2015, and it took until January of 2016 to be able to get the final update for that device. It would be up to the security team of your organization to determine if that device should remain on the network or if you should find other alternatives instead of that thermostat. Another important aspect of lifecycle management is what you do with the device when you don't need it anymore. This would be the decommissioning process, and it's the way that you dispose of an asset once you no longer need to use it. We see this often with desktops, laptops, mobile devices, and anything else that becomes outdated and is no longer supported by the manufacturer. But there's data on that device that we want to be sure doesn't get into the hands of someone else. We need some way to sanitize the media or simply destroy the device to protect all of that data. This might also involve legal issues, especially if there's certain types of data that your organization is not allowed to destroy. So you may end up storing this equipment off-site or in a secure location until such time that it's able to be destroyed or disposed of properly. And what you do not want to do is simply dispose of this in your normal trash. Eventually someone will come across that equipment and they will either get access to the data or they'll sell that equipment to someone else who will then get access to the data. Although we often want to recycle this hardware, we want to be sure we do it in a way that protects the confidentiality of the data contained on all of these devices. An ongoing part of lifecycle management is change management. That's because we are constantly making changes in our computing environments. We're upgrading software on a switch, we're making changes to a firewall configuration, we're modifying a router table, or making some other modification to software or configurations. This needs to be a managed process and something that we can track, monitor, and be able to modify if we run into a problem. Most organizations will have a very clearly defined change management process. This would include how often you're able to make changes, the window that you have to be able to make those changes in an environment, the process itself for installing those changes in your environment, and then finally, a process for rolling back if you run into problems. And if your organization does not have a formal change management process, this might be difficult to implement. You need to make sure that everyone understands the importance of having a centralized change management process and that everyone follows that process before making any modifications to any device. Another important aspect of lifecycle management is how we handle ongoing service requests. This is often done through a help desk. They'll receive a phone call, they'll input a ticket into a centralized process tracking system. Those tickets will be triaged and provided to someone who can resolve the problem, and then they will close the ticket and move to the next one in the list. Almost every organization has a process tracking system, and although there are many different types of software to provide this function, they're all very similar in how they operate.
In 5 minutes, you can find and reach out to a qualified candidate on LinkedIn Recruiter. Using AI-assisted messaging, you can connect with talent easily.
Trust me, you're gonna love how effortless it gets.
Hire smarter and faster with LinkedIn Recruiter today.
It's native.
Good gods, I love native. Yo, we should give this to the mortals. You deserve native deodorant. It's got 6 clean ingredients. And it smells divine. It's not a myth.
It's native.
Change is inevitable, and we need to have some type of process on our network to be able to manage all of these changes. There might be updates to operating systems. We may have to patch a series of devices. There might be updates to applications that we need to roll out. And of course, we have network devices, firewall configurations, new applications that need to be installed, and many other changes that will occur on our network. Instead of simply making a change without any processes or thoughts to what may occur in the future, we need to have a formal process for managing all of these configurations. We need to know when these changes are going to occur, we need to be able to plan for those changes, and we need to inform everyone that the change is going to take place. This documentation becomes very important if this system needs to be rebuilt, especially if there's some type of disaster and you're required to get that system back up and running as quickly as possible. Having some type of documentation that leads you from the installation of that software through all of the changes that you made will be extremely important in getting that system back up and running. When we first install a switch, a router, a firewall, and we make our initial configurations and get everything working perfectly, we now have a production configuration. This is the configuration that everyone will use when we roll out a new router. This is the configuration that will be the standard for that production system. When we install a new firewall, we have a standard production configuration for that firewall. This is not just individual configurations inside the device, but it covers all aspects of changes to that device, including all the hardware and firmware versions, any device driver updates that need to be made, and any updates to the software, especially since there are certain versions of the software that might work better or worse than other versions. This is not something that we would usually install into production to see how it runs. We would usually do extensive testing behind the scenes, make changes to all of these aspects of the system, and then deploy that final configuration into a production environment. Of course, not every possible scenario can be tested in our lab, so we need to have a plan if something was to happen in production to be able to revert that back to a previous configuration. In these situations where something does not go as designed, we need to have some type of backup that we can revert to. This applies to our firewalls, our switches, our routers, our operating systems, and anything else we might be making a change to. The standard operating procedure is commonly to make a backup of that system before making any type of change. Once you make the change, you can then decide whether that's something you want to keep in production, but if there's a problem, you may need to revert back to that previous backup. Sometimes this can be accomplished by simply copying the files that will be updated during that particular change. It might be a single configuration file, but now we have a copy of that file prior to those changes taking place, and we can simply copy that file back if there's any problems. If this is a virtual machine, this process can be relatively easy. You can click a button to create a snapshot of that VM that saves everything, the files, the configuration, and everything else associated with that VM at that point in time. If you run into a problem when you're making a change to the VM, you can then easily revert back to that date and time of the snapshot. This is also useful if later on you decide you would like to revert back to the previous configuration. You now have a backup that's stored either as a snapshot or as separate files that you can then revert to if you run into future problems. When we're deploying a new application, it's usually often more than a single server and a single executable. There are usually many different components that allow that application instance to operate. This might include configurations on the user's workstations, changes to the firewall, and of course the application server itself. To truly understand the scope of this application, we need to document every aspect
It's
of
like
that
we are
application installation.
until
This allows us to create a golden
last
configuration
break
that
of the
certifies that
day.
this application will work properly.
Let's get it in.
All of
I'll
these
see you at
configurations
3
are in place.
after.
We can also use that golden configuration as a way to verify that we are using the proper software and the correct configurations. We can create integrity checks that will compare the configuration running in production with the configuration on our baseline or golden config. If we find there are changes between those two environments, we can make changes either to the production environment to match the golden config, or we can update our baseline configuration so that it matches the new configuration in our production environment. Once we make those changes, we now have a new version of our baseline configuration, and we can use that as our integrity check going forward.
When you're inspired by the 90s, but you want some help incorporating it into your current look, you can just ask Google to break it down for you. Bucket hats? You would rock that. Dress to the 90s.
Aja Rewards introduces the industry's most expansive global rewards marketplace featuring millions of unique products and experiences, all delivered seamlessly through a single powerful solution. With maximum choice and unmatched flexibility, it is designed to create personalized, dynamic experiences for any audience. This is Aja Rewards. Schedule your demo today.
As a network administrator, you will install switches, routers, servers, firewalls, and many other pieces of equipment into your infrastructure. Once you install that equipment, how do you ensure that it's running optimally and that there are no errors or problems that you need to address? One of the ways to do that is by querying this device through a protocol known as SNMP. This is the Simple Network Management Protocol, and it is designed to provide a management interface to these devices over a standard set of protocols, regardless of who happens to manufacture that device. Usually the network team will have a central network management console, and that management console will query devices via SNMP and ask information that it would like to receive. For example, it would request from a switch how many bytes have gone into a particular interface, and that device will respond back with a particular value, and that information is stored in the management station. The query that is being made to this device is querying a number of different parameters that are stored in what is known as a MIB. This is a management information base or central database of data that is stored on that remote device. SNMP queries specific values in that database by referring to an object identifier. Sometimes you'll hear this referred to as an OID or an OID. All of this polling occurs over UDP port 161 and allows us to access any of the devices on our network and gather information about how those devices are performing. When configuring SNMP on your network management station, it may ask which version of SNMP that device is using. There are usually 3 different versions you can choose from. The first is the original version, or SNMP version 1. This provided a way to query those structured tables that are stored within the management information base on this device, but it sent all of that information across the network in the clear. There was no encryption associated with any of the transmission using SNMP version 1. A newer version of SNMP was released that we named SNMP version 2. You'll sometimes hear this referred to as SNMP version 2C. This is an improvement to SNMP version 1 because it's able to query large chunks of data and have a more efficient communication to that device. But that entire communication remained non-encrypted or in the clear, so anybody tapping that connection would be able to see the entire communication. The latest version of SNMP is SNMP version 3. This provides encryption and a number of different cryptographic capabilities such as message integrity and authentication. When we are performing a query to a device using SNMP, we need to refer to a specific variable that we would like to pull back to our management station. That individual variable is called an object identifier, or an OID. That object identifier is a series of numbers. In fact, here's an OID 1.3.6.1.2.1.11.28.0. Each one of those numbers is associated with a particular set of values. For example, the 1 is ISO, 3 is org, 6 is DoD, 1 is internet, 2 is management, and so on. And you can go all the way down this line until you can see that we're looking for SNMP out get responses. That would be the number 28 at the end of that OID. This is how we're able to have hundreds or even thousands of different variables inside of that management information base, and we can query each of those variables individually by referring to their OID. Sometimes these object identifiers are very standardized across devices. One of these standards is the MIB2 standard. It's referred to here as the SNMP v2-MIB. That MIB2 standard is a set of OIDs that are identical across multiple devices. But sometimes a manufacturer has unique variables that are specific to that device. And in that case, the manufacturer will create their own OID. And so you'll need to refer back to the manufacturer's documentation to determine what OIDs are associated with what values within that MIB. Sometimes the manufacturer will provide a file that documents the MIB, and you can add that file to your network management station. At that point, you can retrieve those OIDs from that device and know exactly what that OID is associated with. One of the ways that you can query a device for SNMP information is to use a MIB walker. This is software that will cycle through every possible MIB value and pull down everything associated with the MIB inside of an individual device. This is a MIB walker on my Mac OS device called MIB Browser, and you can see that I have it directed to a host at 10.1.10.64. It's using port 161, and I've configured this MIB walker to use version 2C of SNMP. The default community string on this device is public.
How are you guys doing?
ID is 1.3.6.1, and when I click the fetch button, it begins gathering information about every possible MIB value that could be contained on that device, and when it finds a match, it adds it to the list. For example, it found a number of SNMP v2 MIB values, and you can see the list of those here. In fact, it even pulled back a system ID information, some contact information with my email. It even shows me the name of this system and how I can then correlate that back to a specific physical device. If we scroll down a bit in this list, we can even find individual variables as part of this MIB and see the individual values associated with each one of those. For example, SNMP in get request has a total number of 4, and SNMP in get next has a value of 1,540. If you start collecting that information over time, you can begin to build out very large visualizations of how the network may be performing. For example, this is a graph that has been created through a series of SNMP queries that take place on a standard basis. So you can see that going for an entire day, you can start to map out information such as response time values, any type of errors, or anything else that might be contained within that MIB. This implementation of SNMP assumes that your network management station will be querying all of your SNMP-enabled devices on your network at regular intervals. It would be common, for example, for a management station to query every device on the network every minute, every 5 minutes, or whatever interval makes sense for your management station. But if there's a problem on that device, you may not know the problem has occurred until the next time you perform that poll. For that reason, you may want to configure a different feature of SNMP referred to as an SNMP trap. You can think of this as a proactive alarm that is sent from the device to the management station without the management station needing to pull that device first. These SNMP traps use a different port number. They use UDP 162. For example, you could configure a switch or a router to look for a certain number of CRC errors to occur. And if you get a large number of errors, for example, it increases by 5, that device will proactively send a trap message back to your network management station. As soon as that trap is received by the network management station, it can then alert other people on the network of the problem or start running scripts to help resolve whatever issue that might be. In the MIB walker that we were using earlier, there was a value that we were adding to that MIB walker to be able to gain access to that system. That value is referred to as a community string. You can think of this as a simple password that allows you access to the SNMP data on that device. You can usually set up multiple community strings within a device, so it's not unusual to have a read-only string such as public. There might be a read-write string such as private. There might be a separate string that you would use for traps. These community strings are relatively simplistic, and they're only used for SNMP version 1 and SNMP version 2 or version 2C. There are other ways to authenticate using newer versions of SNMP, and in SNMP version 3,
Welcome back, everybody. We're gonna finish up the last 45 minutes.
network as a password hash. This is a
And
much more secure way
you have any exams to get in, last minute work,
Probably a good
let's
idea.
hit it strong.
At the most
That way, the only thing you have to
secure
worry about
time
tomorrow
available.
is attendance and a test. Attendance and a test. Attendance and a test.
Finding the right IT certification path shouldn't be that hard. So let's cut through the confusion. First, you have A+.
I know, right? It's real now,
This
Mr.
course
T.
covers exactly
Things is
what
getting
you
real.
need. Nothing more, nothing less. It gives you
24
IT
hours.
knowledge made simple. Then, Dion Training offers Network Plus certification training, which gives you network infrastructure expertise. In Dion, students just master Network Plus concepts way faster than the traditional way. And then we have our Security Plus certification. Now, on average, this is said to give $15,000 more in your salary per year if you have.
On your network, you're probably using routers, switches, firewalls, and many other network infrastructure devices, and all of these devices are running 365 days a year, 7 days a week, 24 hours in every single day. We'll need to monitor these devices to make sure that they remain up and running, and we may want to query those devices to determine what type of load they're seeing, perhaps log file information, and other details from each individual device. This allows us to see if people are able to authenticate properly to the device, if there are any security concerns, or how much utilization may be used in CPU or network. Many times the network administration team will have a central console, and that console will roll up all of this different information from these many different sources, put everything on one single screen for analysis. One of these data points gathered by this network management station could come from a service known as NetFlow. NetFlow is a summary of statistics based on the flows of traffic that are traversing the network. NetFlow has a standard way to collect this information from these devices, and there are many different NetFlow products available from many different manufacturers. NetFlow usually starts with a probe that you would put onto your network. This probe may be sitting in the middle of the connection using a physical tap, or maybe using a switched port analyzer interface on a switch to be able to gather that information. Raw packets are being sent to this NetFlow probe, and that NetFlow probe is compiling statistics based on all of the packets going across your network. The summary of all of that information is then sent down to a single NetFlow collector. This means you don't have to go to separate NetFlow probes to be able to gather all of this detail. You go to the single collector, and you can create all of your reports from that one central place. The collector is not only keeping a database of all of this information over time, but often the collector will also include a report generator. This might allow real-time reports and summary views on your console, or you may be able to configure long-term reports to be generated every day. This is a NetFlow console, and the current screen is showing a NetFlow traffic analyzer summary. You can see that it contains top 10 conversations, which are ingress and egress data for all of these devices. This is over the last hour. You can also see a top 10 endpoints on your network. This is listed by IP address or the name of the device. Here are the sources of that NetFlow data, and you also have traffic analyzer events that are coming from those NetFlow devices. NetFlow can also summarize information by port numbers so that you can see how much application traffic is traversing the network. These are the top 5 applications on this network. Looks like SSL is the largest amount of traffic on this network, and then there's SQL Server, other web traffic, NetFlow UDP traffic, and port 0 traffic. All of that NetFlow information is effectively metadata that was created based on the packets going across the network. But you can also view the raw packets themselves using a protocol analyzer. This allows you to see the exact bits and bytes sent across the network from one device to another. Protocol analyzers can collect frames from a wired network, a wireless network, and it can present this information in a form that is easy to read. Instead of viewing all of the hexadecimal data, you can view a summary of these packets going back and forth, and then drill down into the details associated with each packet. If you're trying to find unknown traffic or you're working to troubleshoot a slow application, you can view all of the conversations taking place over the network using this view inside of your protocol analyzer. And in some organizations, this data is also collected and stored over a long time frame. This usually includes a very large array of storage drives, and every packet from the network is being stored on those drives for later analysis. Once we begin gathering all of this data from these many different data sources, we can start building a picture of what a normal day on the network might look like. We refer to this as a network performance baseline, and this can be a very useful set of statistics, especially when we begin troubleshooting the network. If you're trying to determine if a large amount of utilization on the network is normal, you simply look at your baseline to know what the normal amount of utilization would be during a standard workday. You can then compare that to the value you're seeing now, and then determine if that's better or worse than what would normally occur on the network. We can also drill down into these baselines to see what normal performance might be for an individual device, for example. So you're able to get a very detailed view across many different devices on your network by simply compiling this data into a central baseline. If your organization is using a management console or a SIM, this would be a security and information event manager, then you may already be collecting data files and other useful statistics that you can use to build out a performance baseline. This management console or SIM console may be able to look through the data and identify an alert when certain anomalies occur, or it may be able to present normal baselines for an extended period of time so that you can see when things happen to change over a normal workday. That management console or SIM console is collecting log files from many different devices. There's log files inside your switches, your routers, your firewalls, your servers, practically any other device you would connect to the network. There is a standard way to transfer log files from all of these devices, even though each one of those devices may be manufactured by a different company. This standard for transferring log files is known as syslog. You'll usually see the syslog configuration inside of your switch or router, and you'll tell the switch or router where to send all of its log files using that standard syslog transfer. This is commonly sent to a SIM, which is a security information and event manager, and usually we are storing that on a large drive array inside of that SIM. That SIM is identifying what device sent that log file. It'll identify what's known as a facility code, which is the program that originally created that log file, and it will also include a severity level for that line within the log file. So you should look at the configurations in your enterprise switches, routers, and other devices to see what options you might have for sending that syslog information to your SIM. If you were to log in to that security information and event manager, you would find a large amount of information available to you. It's not just page after page of this log information, it's also all of that information rolled up into reports that you can then use to make decisions. For example, there might be a dashboard on the SIM that gives you a real-time status of information about your network. You can see alerts and alarms if there happens to be a large number of failed authentications, or if a device happens to go offline, you may see that in the dashboard of your SIM. Most SIMs also have very advanced reporting capabilities, so you may be able to go back in time, start comparing and contrasting different statistics across multiple devices, all using that large database that you've compiled within the SIM. So you might be able to track application usage when it starts on a server. You can track that traffic as it traverses a switch, watch that traffic as it goes through a firewall, and then analyze how much utilization that's taking on your internet. And since you've now stored all of this log file information over an extended period of time, you might be able to use it for forensics. This will allow you to go back in time and track when someone may have authenticated to the network and then which services they may have used when they were logged in. This log file information can be sent from nearly any device. This could be a NetFlow collector, it might be a server that has syslog capabilities, or it might be a switch, a router, or a firewall that's currently running in your infrastructure. One of the things you may find when you first turn on a SIM and start sending it syslog data is that it will be receiving a large amount of information. Some of this information might be useful for that individual device, but it may not be necessary to store that for a long period of time within your SIM. So you may want to change some sensitivity settings on the SIM to be able to perhaps only capture warning or urgent information and perhaps not store informational details within the SIM database. Here's an example of an ad hoc data query made on a SIM. You can see that we're doing a query here for anything that starts with fail, so this might be failure or failed, or the word fail itself, and any records that include the word password. So we're looking for situations where password authentication has failed or is not completed successfully. And you can see the series of statistics that are gathered. This creates a single chart across the top, and then we can view individual event records. For example, these appear to be event records from Windows Server, where there is a login failure. It says unknown username or bad password. The username used for that authentication was Hacksaw. You can see it's Acme Text domain, and it has a login type and other lines associated with that record. We can now track this over a long period of time to see, is this normal, or have there been instances during the day when there's been a large number of failed authentications? This might be able to identify times during the day when there would be a brute force attack or a password spraying attack, and then we can use additional security tools to track that closer or to prevent that event from occurring again. If you've ever had to administer a switch, a router, a firewall, or any of these other infrastructure devices, you know that you would normally SSH into the device, perform a series of commands at the command prompt, and then disconnect. And if you need to make that change again on a different switch or router, you will need to SSH to that additional router and make those changes again. This is something that can be relatively tedious and almost impossible to manage in large environments where you may have hundreds or even thousands of these devices. For that reason, we need some way to automate this process. We can do that by using API integration. This allows us to have a central management station communicate directly to a switch, a router, a firewall, or some other device using an application programming interface, or API. This allows us to create applications, scripts, and other programs that can communicate directly to that device without using the SSH console or communicating to that device over a web console. This means that we can effectively communicate with the native language of that device. So we can send commands, make configuration changes, or query information on that device without having to interactively log in or sit at an SSH prompt and look for that information. And if you're managing those hundreds or thousands of devices, you can make those changes automatically with one click of the button using this application programming interface. A lot of the monitoring and features we discussed in this video needed the raw packets from the network to be able to gather those statistics. One of the ways to gather those packets is using port mirroring. This allows you to use an existing switch and redirect traffic from one port on the switch to a packet gathering device that you have connected on a different port on that switch. We also use port mirroring for security features such as an IDS or IPS, and we may also use this for performance monitoring. For example, we might connect a NetFlow collector to one of these port mirrors. Some switches even support the ability to mirror traffic from one switch to another, so we could have a switch in the data center with our monitoring systems and be able to gather packets from a network switch that may be in another building or another location. The port mirror may also be referred to as a switched port analyzer or SPAN, or we may have a physical network tap that's connected somewhere between two devices. If we are using a switch, we're simply taking a copy of this data and sending that copy to a third-party device such as an IPS or NetFlow collector. So when a user is communicating to a server, they first are communicating through a switch. So a copy of that data is sent to our IPS, and the original copy of that data is sent on to the server. We can do this for single interfaces or multiple interfaces or VLANs on the same switch so that we're able to see all of the traffic that is available on that switch.
When your question question is actually a bunch of questions.
When's the best time this weekend to host a backyard barbecue? And what's something impressive I can grill that I don't have to stand right next to the whole time?
Just ask Google.
When you sit down to troubleshoot a network issue, you're starting with no information. So we need to start gathering more details using a number of different techniques. These would commonly be things like LLDP, which is a link layer discovery protocol on switches. There's also CDP, which is Cisco's version of this called the Cisco Discovery Protocol. You might also use scanners that are able to perform ping scans or port scans of the network to identify devices that may be up and running. It may also be commercial network scanners in place, or you might use simple network management protocol. Some organizations will run these types of scans every night on their network to gain an understanding of exactly what devices may be installed. Or this may be a scan that we simply do anytime we're trying to do some troubleshooting, and it's not something that commonly runs every day. But if you do have a daily cycle of scans and information gathering, and you can perform reports on that information, you may be able to build an interesting view of exactly what type of traffic is on your network and what devices may be sending that traffic. We often refer to traffic analysis as a detailed frame-by-frame or packet-by-packet description of exactly the traffic that's flowing across the network. Often this is summarized into simplified views so that you don't have to sift through hundreds or even thousands of lines of frames just to understand what type of traffic went across the network. For example, if you were looking at a detailed firewall log, you would be able to see exactly how much traffic was sent across the network at which time frames. You would know which IP was the source of that traffic flow and what IP address was the destination. And you might also be able to gather additional details such as the port number that was used, the application in use, or exactly how many bytes were transferred between those two devices. And if you're collecting this information and storing it over a long period of time, you can use this for creating long-term reports or being able to go back in time and perform detailed forensics. Here's a view of this firewall log. You can see there are a number of different columns of information that are collected. One is the timestamp of the traffic flow. You can see in this view it starts at 7:49 and 38 seconds and goes down to 7:44 and 57 seconds. There's quite a number of traffic flows that have occurred on that network during that time frame. You can see the protocol in use, whether it was TCP or UDP, and you can see port numbers are also listed in this log. We have a client IP address and a server IP address, so we know exactly what two devices were communicating with each other. And if we have a DNS server, we may be able to take those IP addresses and convert them into host names. In this example, the host name is the same as the client IP address. This provides us with a wealth of information for every single flow of traffic going across the network. So if you were ever wondering if someone was able to see exactly what you were sending across the network, there may be ways to gather a great deal of that information using these firewall logs. If we're troubleshooting a problem, we may be interested in overall performance from that device. This might include network utilization statistics or an overview of any errors that may have occurred on that device. You can usually gather this type of information using SNMP, the Simple Network Management Protocol. Maybe you're gathering net flow statistics, you're doing protocol analysis and looking down at the frame level, or maybe there's a software agent running on that device and it's providing you with a summary of this performance information. Based on these statistics, we can begin to understand if our network is highly utilized, if we're seeing a large number of errors, and try to get an idea of where the problems may be occurring with that device. Sometimes the statistic that is most important is a device up or is a device down? We can find this information by looking at our availability monitoring. This provides us with green for up and red for down. We can instantly see where a device may be active or where it may no longer be on the network. This can also be rolled into a set of alarms and alerts, so we can constantly monitor these devices, and if any one of them happens to turn red, we can instantly start sending email messages, opening up help desk tickets, and sending alarms and alerts to the people that can solve this problem. The view that we have here is a real-time view of the devices and whether they're up or whether they're down. But we could also collect this information over time, allowing us to build a report that shows overall performance and availability over an extended period. This is obviously a very simple metric. The device is either active or the device is not active. If you need additional details about the performance of the device, you may have to drill down deeper to gather net flow statistics or information via SNMP. All of the devices on our network have configuration files. These may be files that we can easily see and list on the screen, or they may be stored in different places on the switch, the router, or the firewall. Many of these devices also allow us to back up the configuration files and restore those configurations if we need to update or make any changes to the device. These configuration files might also be specific to a particular version that's running on that device. So if we have an older configuration file and a newer version of software running on that switch or router, we may not be able to load that older configuration file back onto that device. In those situations, we may need to downgrade that device back to that previous version just so we can now install that older configuration file back on that switch or that router. This means we not only need to collect our configuration files and store those for future reference, but we also need to keep our firmware or previous software versions just in case we need to go back to that previous config. If we have multiples of these devices, we can also compare and contrast the changes between those configuration files on all of those different devices. For example, you might have 10 identical web servers, and each of those web servers should have a very similar configuration. There may be a way to use the configuration files to be able to verify the configuration across all of those. Many organizations will also perform ongoing monitoring of those configuration files, and there will be an alert or an alarm if anyone makes any change to that configuration without prior approval. This is usually part of an overall management system that is integrated with the change control within your organization. So you may have software that's monitoring the configuration files and a larger process that is involved with changing and modifying those configuration files in a very standardized way.
All right, team, USAA is open to
spouses and kids of military who joined, like me. And grandchildren if their parents join. Are you eligible, Coach Bob?
It's complicated.
USAA. Become a member today.
Airheads.
Most organizations will create a plan that they will follow if they happen to have an outage or a significant problem that could affect the overall goals of the organization. This is often referred to as the Disaster Recovery Plan, or the DRP, and it will cover every aspect and detail of how to handle these situations when they occur. And if you think of all of the different types of technologies involved in recovering from a disaster, it is many and varied. You have backups that you need to consider. There may be off-site data replication that might be involved in this disaster recovery. Perhaps you set up alternatives that are located in the cloud. So instead of having a server on site, we can create that same server in a cloud-based environment. Or maybe you've got a completely separate remote site and you move all of your operations to that fully operating remote location. There are also many third parties that can provide additional services for disaster recovery. For example, you can contract with a third party that will provide you with a location so that you can move your operations to this temporary facility. Or you may want to contract with recovery services that can come into your organization and manage the process of recovering from a disaster. There are many different metrics that can help us understand the scope and the breadth of an outage. One of these metrics is a recovery time objective, or an RTO. This is an amount of time, and we want this RTO to be as close to zero as possible. RTO is a measurement of how quickly we can get back up and running if an outage is to occur. So we need to define what a normal service level would be, and then we can calculate how long it will take to get to that particular service level. We refer to that gap in time as a recovery time objective. For example, we know that if our web server was to fail, that the normal recovery time objective for that web server becoming available again is approximately 1 hour. So 1 hour would be the RTO for that outage. Another useful measurement is an RPO. This is a recovery point objective. This is also measured as an amount of time. And again, we would like that RPO to be as close to 0 as possible. RPO represents how much time we lost when that outage occurred. We have a certain amount of data that goes back in time that was not stored, it was not backed up, and when that outage occurs, we would lose all of that data. Generally, this is a value that you've already determined. You would make this determination based on what resources you have to recover this data and the types of backups that you may be doing throughout the day. And this RPO may be different depending on the type of business you're in. For example, if your organization handles banking transactions or you manage patient information, you want to be sure that you don't lose a lot of that data. So you may put methods in place to be sure that you are only losing a small amount of time when an outage occurs. This might be, for example, a very short time frame that would be less than an hour. But maybe your organization works with other types of data that don't require such a short RPO. For example, any updates to your website or updates to internal documents may only be backed up every hour or 2 hours. So there would be a longer RPO associated with that type of data. If we were to look at both of these values on a timeline, you can see that as time is going by, we have a certain data recovery point. Maybe this is where data is backed up. Maybe we are replicating data to a different site, but we are making a copy of that data or storing that data in a way that we could recover later. Sometime after that point, we would have an outage, and the time that we have between that outage and the back in time period to that data recovery point would be the recovery point objective, or the RPO. So now we're focused on resolving this outage. We need to resolve the issue with the servers, deploy new servers in a different location, move the data center to a backup site, or do whatever we need to do to recover from this disaster. And then finally, when our services are back online, we can measure that time frame between the outage and the online time frame as a recovery time objective, or an RTO.
As a special operations soldier, I've served downrange and outside the wire. You deserve an attorney who truly understands loss and pain, and I don't use those words lightly. In Hoyser and Hoyser, you're our brothers and sisters, whether you served or not. We're on top of it.
When these issues occur, it's useful to know how long it's going to be to resolve this problem. And it might also be good to be able to predict when problems might occur. We can provide estimates for both of those values by using MTTR and MTBF. MTTR is the mean time to repair. That is, on average, how long it will take to resolve the issue associated with that particular problem. Maybe it's a router that's failed, and we need to replace that router to get back up and running. The average time frame for replacing that router would be our mean time to repair. A better plan might be to use systems that are designed to stay up and running as long as possible. So we would need to put in equipment that would have a very long mean time between failures, or MTBF. The MTBF is generally based on a number of criteria, but it's presented as a single time frame. For example, if you purchase a firewall, that firewall's MTBF may be 20 years before you would expect that device to fail. So you can then make disaster recovery plans around that time frame. If you see that your firewall has an MTBF of 20 years, you might only need one additional backup unit instead of purchasing multiples, because you know that device is going to last, on average,
All right, everybody, as promised at 5:30.
If we're dealing with a significant disaster, we may
We're
need
gonna
to
go over
move
part of
our
domain
data
4.
center and into a temporary facility. But making that change is
So
often
we
not a
have,
simple
and what
process.
you
There are a
might
lot of
see
different moving
on
parts
the
that
exam.
have to happen to move your entire data center from one location
Domain
to
4
another.
is talking
And then
about
once you
security
move to another
concepts.
location, you then have to move everything back.
A couple of things you might see.
We refer to this movement
Starts talking
of
about
one location to another
logical
as
security.
site resiliency. One example of
Now,
the
when you
site
see
resiliency is
logical
the process
security
you go through
and
to
physical
prepare that
security,
disaster
they are
recovery
different.
site. You need to make sure you have power.
Logical security talks about the connection,
Prior to a disaster,
the
you may want
interface
data
connection
transferred over.
of an
Once
item.
that disaster occurs,
IP,
you have a process
certs,
where you
all
go
these
from
different
the
things. With
primary
physical,
location to this
we're talking
backup
about putting
facility.
a camera in
You
place,
can
locks,
work
physical
with
locks,
backup
power locks,
facility
stuff like
until the
that.
problem is resolved at at the main location.
Let's not get it
This
confused
might
there
take an hour,
with there.
it might take a
Now, we
day,
talked
or it
about
could take months,
data
depending
in
on the
transit,
problem that's occurred.
data at
Every
rest
disaster will be
before
different, and we have to
Ms.
think
Jewel
about
came
that
in.
time frame when we're
Public
preparing
key
to
infrastructure, we
site.
talked about the
One of the
PKI,
ways
how
that we are ready to
certificates
move back to the
can
original
be
data center, there is
assigned
another
from the
process where we
CA
take all of our
or
assets and our
the
data and move it back to the original
intermediate
location.
certificate authority,
If
an
you're going to be
authority that
using a
has
separate
permission
disaster recovery
to
site, there are a
issue
number of different
certificates
ways to
on
set up your
behalf
particular
of
facility.
the
One
root
is with a cold site.
certificate authority.
This is effectively
Okay.
an empty building. None of our equipment is
When
in
it
the
comes
building,
down to
none
it,
of our
all
data
of you
currently
are going to be
resides
responsible
at this
for
location.
identity
We
and
need to grab
access
backup
management.
tapes or equipment
Identity
that has
and
our
access
data and
management.
move it to this location to be able to perform
You may see this
disaster recovery.
when you're looking on
We
job
also have new
interviews
people
or
at
looking
this
for job
location,
postings,
so we
excuse
may
me,
need
for
to
IT,
transport people from one
especially for
location to
government.
another so that
It's what
they
they
can
call
work
the
at this
8570
particular
rule.
site. This obviously means we have a lot of
8570.
work to do if we call a disaster, but it also means that this is a
Let's take a look
relatively
at
inexpensive place to use as a backup
units.
location. If you needed to have a disaster site where you could very easily move in and be up and running, you may want to consider a hot site. A hot site is an
One
exact
second.
replica of your data center, or as exact as you can make it for something that's a disaster recovery
For
location.
8750, I
This
think
means
that
it has
Yep,
the
it's
same
8750.
hardware
I
that you
believe I
are
was told.
currently using in your
Now,
existing data center.
with
And
the
it's very common when
8750,
you're purchasing new equipment for a data center,
talks about
that
the
you also
DoD
purchase
directive.
additional units for your hot site. And of
The
course, not only do we
8750
need
rule. Had
equipment
it
at this hot site, we also need our applications and our data. It's very
If
common
you are
to
looking
have
for a job in
replication
IT,
systems or ongoing backups,
this is
so that
important.
the data at your hot site is as close to the data that you're running at your primary
And,
location. And by putting
the
all of this in place,
8750
on
is the
site, we
baseline,
can
but
then
now
move
trying to
relatively
get
quickly from our
to where it's the
primary data center
8140
to this
because the
disaster
Army
recovery
runs the
location.
8140.
And since we don't have to install
That
any
is what's
hardware,
going to start
install any
taking over
applications, or recover data from
8750.
backups, we can be up
Make
and
sure you
running
bookmark this. I gave you the link.
quickly. A
This is the
work site
minimum
is
requirements to
something
get a
in the middle
job with a
between
third-party
cold site
government
and a hot site.
contractor,
This is a site that might have some level of infrastructure. It
GS,
might have
government
power
services
and racks. In
employee.
some cases, might
If you're
even
looking
have
at trying to
hardware
get
that you could use.
a
So
job
what
with
you would
them,
need to
this
do
is
is
what
go
you
in
need.
through data, recover from your backup
Okay,
tapes,
download that
up and
PDF
running.
when you have a
There's
chance.
different levels of service that you can
These
use
are
on one
the
site. You can
levels.
decide
These
just
are
how
the
much hardware
technical
or how much
levels.
data you would
Identity
like
and
to
access
save at
technician.
that
You're a
location.
technician.
It's always a good idea
Management.
to practice
So down
and
here,
run
you're
tests
fixing
so
stuff.
you know
Down here,
exactly
you're
what
managing
to do
stuff.
should a disaster occur.
Okay.
But that process of going through a
Most
full-blown
job
disaster
postings will
recovery
say,
test can be
if you
relatively
want to just
complex.
fix a
This will get
computer,
people out of their
you're not
normal
managing a
jobs,
system.
perhaps in some cases,
All you need for
safely a
IAT
separate
level
location to be
1
able to
is the
perform
A+.
an actual disaster recovery test. Instead of
CCNA
going through a
security.
full-scale test, it might be useful to have everyone
I have to look and
sit
see
around
what
a
C&D
conference
is.
table and go through the
Or Network
process that
Plus.
they would follow if
Okay.
a disaster was
Level
called.
2, they start
This would
bumping
allow
you up,
all of the
saying you
different
need
departments in
IAT level
IT
2,
and all of the management of the
CCNA,
company to
CYSA
step through
plus,
problems and
C&D
describe
and
what
security
they would
plus.
do in those particular
That's to get a
situations.
CAT
We don't
card.
have to go through the physical
Okay.
process of going to
Any
their backups,
IAT level
taking
2, where you can
them
get
to
a
this
card, a
location,
common
but
access
it does
card,
require that
and put it to the
everyone
computer
step through the
network to
process
manage the
so that
network.
all the logistics are in
And
place
then up
to get
here,
that data
IAT
from
level
one
3,
location to
you're
another.
still going to get a
Since we're all
card here.
sitting around
So
the
anything that's
conference
level
table
1,
to be
it's
able
ground
to
level here.
describe the
You're just fixing
process
stuff.
that we would follow,
Okay.
we refer to this as a tabletop
When it gets level 2 and above, now you are actually logging into a device. Here's the security feature. All of this is security. They know you're going to secure the device at the same time and as
There are
this
some
level.
organizations, though, that go through a full
Identity
disaster
access
recovery
management.
site either once a year or
If you
multiple
want to get to
times
the
a year.
management
So it's
level,
always good to go through these validation tests. That
you
way, if
can't
a
have
disaster
anything
occurs,
less
everyone in the
than
organization
one of
knows
these,
exactly
depending on
what
what
to
level
do.
they're hiring for.
When you're running through these validation tests,
CISP is now, you're a
actually
practitioner. When you get up here,
production environment into your disaster
you are sort of a
but you are going through exactly
practitioner,
the same process.
meaning you can pick
Usually these
apart what's
validation
going
tests will
on
follow
with
a
the network.
particular scenario.
Forensics,
For example,
you're doing that
let's
type of
say
stuff,
a fire was to destroy the building where your primary
right?
data center is.
CYSA,
There would be a
you are
series of
at a
processes and steps
SOC team, security,
to the disaster recovery site. Well, what if the
scene,
scenario was
you're doing all that
this,
stuff
where
here.
everyone
When you start
in
getting
the
over here,
geographic area around
now
the
with
data
CISP,
center
you are
had to be
analyzing,
evacuated?
you are
In that
doing
situation,
reverse
there might be a different set of steps to be
engineering.
able to get
You're
all the
figuring out how they got
all the
into the
data
system.
from your primary
what vulnerabilities allowed you to be exploited, right? You're doing big briefings with people. This is what you're doing. And when you get up to the architecture, system architecture and engineering, you are putting together the system logically and physically. You are designing it. You're the architect. So on and so forth. And if you want a cybersecurity role, you got to add these. Now, you notice that there's a couple of them that are in all the categories, or close to all the categories.
Yeah, CYSA.
Cloud Plus, CYSA, CEH, Ethical Hacker, that's a white hat ethical hacker, and CISP. Those four seem to be everywhere. Okay. Indeed.com said their demand is going to rise by 33%. But they also say if they require a certification in each one of these levels, not one cert can check the box for each one. They want you to have at least another cert that complements for that level. You understand what I'm saying?
Yeah.
They just don't want you to walk in a job with CYSA. Oh, CYSA covers all of that. They're like, no, you need another one. Either Security Plus or CYSA, CCNA Security or CYSA, CISP or CYSA. So they want you to have some dual kind of combination to cover. All right. So please keep this in mind when you're applying for roles, and you can refer back to this to see what they're looking for. Anybody can get a job here, but if you want to move up in IT, that's for the government or it's third-party services. You gotta make sure you got these. That's why Security Plus in this 12-week program, you gotta have that. Now, do I think Security Plus is the most important one? If you want my opinion, Net Plus is. Because if you don't know how systems work, how are you going to guard it? So Network Plus to me has a little bit more value than Security Plus. But if you want to get out and immediately get a job on a network, you got to have Security Plus. You can kind of learn on the fly, right?
Yeah.
So you can learn the rest of it on the job. But Network Plus and Security Plus together, yeah, you could probably walk in somewhere and be good to go. All right. Okay, somebody look. Aaliyah says C&D Certified Network Defender. Okay. I have not heard of that one before. But okay, that's good. So I just want to show you that.
Yeah.
Now, as we get back into, and please save that link, everybody.
For the 8140, okay.
When we see it here with identity and access management, now that we understand what it means, and we've seen it, you have to control multi-factor authentication. There's several ways you can verify that a person is actually asking for a new password reset. You are verifying through a third-party out-of-band resource, sending something to their phone that they should have on them, a token or something to say, this is multi-factor. I know you just put in your password in your email, but before we totally let you in, let me put in this code for me. That's multi-factor authentication. Single sign-on. This is where people get confused with single sign-on and what they call federation. There's two of them. Okay. I don't know if federation was presented to you while you were going through the new Net Plus 009. However, let me explain the difference. If you are using single sign-on, you are using multi-platforms inside one enterprise
For example, you might have data
to access
the network
things
in different directions. Maybe one part of the conversation goes
Alright.
to one device, and the return.
And you are usually being verified through a CASB,
You need to have some
a Cloud Access Security
all of these
Program.
different data flows and what
I meant to say SSO, that's SSO, not so-so-def, just
design work and
dad joke.
exactly
Anyway,
where the traffic flows are in the
but
network, how the
So deaf or
routing
SSO.
switches are located, and how you would
That's what
expect
you're going to
traffic
use
flow on a
to
normal
get into,
basis.
let's say, a
As
Microsoft
you would
suite.
expect, with an active-active
You
configuration
have your
where both
email,
firewalls
you
are
have
operating
Teams,
simultaneously, you can send traffic to the network.
Access,
One traffic flow may go
and
to
many
the
other different things that it may have.
and a
But
secondary traffic flow
but
may
instead of
go
having you
to
log
the
into
alternate
each
or
part of
secondary
that
active
suite
firewall.
individually,
If one of the
we'll just
firewalls
use single
doesn't
sign-on.
fail, you don't
Once
have to
you're in
worry
one,
about
you can get
failing
in all of
to
them.
a secondary because both firewalls
Okay?
are already active.
The
The
benefit
firewall
about that
between
is
will continue to handle the load.
it helps
Traffic
prevent
will
you
continue to
from
flow
forgetting
normally
your
through the
password. So it's dope on that aspect. But what's the drawback of that? What's the drawback of single sign-on?
When you're inspired by the 90s, but you want some help incorporating it into your current look, you can just ask Google to break it down.
So one organization or you can cross multiple platforms to sign on to or into suites of things. Compromises everything. You're correct, Mark.
Whether you decide
Right
to
on
stay
time.
in
All
or
right.
go all out.
So there's a benefit to it, but the drawback is once they get in one, they get in everything. So they'll use a cloud access security broker, single sign-on. That's why you can use your global email login for Google. Dang near let you in anything nowadays, right? Because here's the thing. When you signed up for an email account, they got your name, address, emergency recall email just in case you get locked out. They can hit you up with a phone number just to make sure it's you. Guess what? Google's a CASB. They're a cloud access security broker. So they don't get it twisted. They got you on roll with a free email so they can become a CASB. You are now a participant in the CASB brokerage. So now they say we got 25 billion users. Hey, all you other tiny little websites, do you want to pay us to be an access broker to use single sign-on for your company application? Sign me up. So now they put this little thing in their website saying, would you like to sign on using your Google single sign-on? Button goes. Now this is what happens. When you use single sign-on to get on, you present your private key. Their website presents their public key. That's where it stops. They say, do you trust? They use Google Cloud in the middle as the trust. That's why they don't reveal their password. You never reveal your password. The CASB creates a secret password in the middle and then lets you go to it. That means they can break the trust with you anytime they want, and you could break the trust with them anytime they want, and y'all haven't given up anything. Makes perfect sense, right? So both of y'all could walk away from each other. If you ever want to terminate that login relationship, you could walk away from each other knowing you never gave a password or never gave a login. Well, your email was your login, but you never gave away a password.
There are other devices on this network that we're simply not showing in this particular.
Yes, you're correct, Michael. They're starting to get away from it because now the cool thing is called passkeys. That's where everybody's moving to right now. But just to understand how single sign-on works, that's what it is. Now, federation, if you haven't heard it, federation means you're a part of a huge organization, and now your login can cross multiple domains. Here's an example. The DoD, the Department of Defense. Big organization, right? Guess what? They're a company. They have how many subdomains? USMC, Navy, Air Force, Army, Space Force, the reserve component. And I think there's another. I want to say Coast Guard. All right. So they got 7 sub-companies. Guess what? If you are part of any of those, you are federated. When you went to MEPS to join the Army or the Marine Corps, whatever you went into, the Navy, all of your stuff, your PII, is used to federate you in the entire federal defense system. That means if Michael is putting up some satellites for the Air Force one day or the Marine Corps one day, and then he gets a phone call, hey, the Army's short some folks, we're going to send you TAD to such and such and such, you're going to help out a lane. He's working with some Apaches, he's going to need your help. The minute Michael leaves the United States Marine Corps base, goes over to the Army base to help a lane, if he puts his CAT card in the system, 9 times out of 10, he can get onto the system. The only thing he can do is surf the internet. That's it.
Yeah.
To do anything else, the local IT needs to give him rights and permissions to do what a lane can do. So he has to see the local IT administrator that a lane works with to ensure Mike can help him do the job. You understand what I'm saying? So that's federation.
This one is for the curlies. Tingles are out, moisture is in.
When we have these type of things where if you need to go into, let's say another enterprise, a company, logging in from external to go internal, you have 2 ways you can do it. You have the radius, the remote authentication dial-in user service, which is radius. That's a AAA server.
So in step 3,
What's AAA stand for again?
is going to choose one of those offers and send a DHCP request.
I see it on the exam, so let's spell it out today so we can kind of have it in our minds.
Coming from 0.0.0.0 because Sam's workstation still does
Authentication, accounting, and what's up?
UDP port 68, and the destination is going to be
Access.
255.255.255.255.
So the radius server is going to make sure all of that's done. The TACAS Plus, the Taco Tuesday, Terminal Access Control System Plus, but I still can't remember IEEE. Whew. How do you get that? I don't know.
That's
Listen,
AAA.
the Taco Tuesday is used for people, which are you, these security professional, the IT professional. You log in through the TACAS Plus remotely to administer all of your devices. Your core devices, your switches, your layer 3 routers, right? Anything else, your IDS, your IPS, your UTM, Unified Threat Management System. Even through your proxy, you can get in and administer these things remotely and troubleshoot. Okay. Next, we have what they call the LDAP, Lightweight Directory Access Protocol. You will see this on the exam, so please give us the port number. Port number of LDAP.
What is it? 161, 160.
Limitation associated with the DHCP process, and that is the broadcast.
Is it 636 or 389?
Broadcasts, of course, are only transmitted to your local subnet, and none of those broadcast frames will traverse a router.
I believe it's 389. Yep, I think it's 389, Mark. Because I always marry up LDAP with radius. LDAP secure is 636. Yep. All right, so remember those 2 ports. Not to say you can't, there's a lot of stuff to remember, but those 2 will probably scream at you for one question.
Yeah.
All right.
Also might want to centralize these DHCP
Security assertion markup language. Most of you would be like, James, we didn't cover that. Probably didn't. That's why we're covering it right now. SAML. Okay, this is what's going on. Michael has a system. Right? He's had his satellite system over here for the United States Marine Corps, where they made a deal with the Army saying the Apaches need to use it. I don't know what these do. I'm just go along the story lane. I know I'm probably not on track here, but I'm just doing an example. He sets it up. The lane talks to Michael. Michael, this is what we need to do so our Apaches can use your satellite. Rent some space, right? So what they do is a lane sets up security assertion markup language in XML format, because XML is sort of a common lightweight language that can be exchanged between a lot of databases and servers. Okay? And basically, Elaine and Michael say, okay, we're all streaming through the same, our systems need to talk securely, and because we're using the same satellite to bounce stuff off of or whatever.
Yeah.
So they agree, let's put a little extra layer of the sandwich. Let's put an extra layer. So here's the lettuce. SAML.
Encapsulate it. Yeah.
Okay, we need to add some SAML, Michael. Okay, gotcha. We'll put it in there. It's a security markup language that both our systems need to use to talk to one another to make sure it's secure. Bam, that's it. That's all you need to do. That's all you need.
Works exactly the
All right.
same, but in reverse. The offer leaves the DHCP server and is
Next, we already covered TACAS. Next, we have time-based authentication. There's one word that goes with time-based authentication. It's a security. We use it for security. Access to the system. It's time-based. Time tickets. Time tickets. You're correct, Aaliyah. It works directly with MTP, port 123. ABC, if you believe in me, and then we can see. You're right, Aaliyah. Kerberos. Time-based authentication, Kerberos. As she mentioned before in the chat, it works off the NTP protocol 123. Which one is the atomic clock? Stratum 0, Stratum 1, or Stratum 2?
Of the atomic zero?
There's one question about this on the Net Plus. There's a question. I answered it. Which one is considered the atomic clock, the original, the OG of time? Everybody gets their time from this. Is it 0, 1, or 2?
So in this video, we'll look at some of those DHCP configuration settings.
Stratum.
When a device requests a DHCP address, the DHCP server refers to.
You were correct, Mike. You got it. 0.
That are defined with
Stratum 0. You know the 0 is common in most connection types because it's usually a direct connection.
It's that's the default.
Quickest response. Stratum 0. 0.
You also have your subnet mask,
0.
scope,
0.
also lease duration,
Ad hoc connection. 0. Cost path analysis. Okay.
There's other options that you might include. Such
All right.
as servers that need to be configured.
Let's talk about least privilege.
Optional settings such as voice over.
You don't want to just vomit permissions on people when they come in. I don't know what you need. I'm gonna give you everything. No. Don't do that. We start you off with the little stuff. We're gonna walk you through. You gotta prove to us that you need this other stuff. That is the principle of least privilege. Okay? Correct. Not only just read, write, and execute for file access, it's also to navigate the network.
Yep.
Right? So yep, you're correct. All this stuff y'all are putting in the chat. So navigation of the network, lateral movement of the network, accessing to get the read, write, and execute. We need to make sure we monitor that when you first get in. We just don't want to give you everything. Then you have role-based access. Okay? Here's the role-based access. Let's keep with the same thing. Elaine's got the Apaches. He's waiting for Mike to come. He's coming over from USMC over to the Army base. Elaine's picking them up. He's walking them through. He says, right now, Mike, I know you know what you're doing. But one of us needs to be the deciding authority or QA. One of us needs to be the worker. We can't be both, right? So they decide, okay, Elaine's going to be like, well, let's do this. Since I know the system, like the back of my hand for this aircraft, I'll be the supervisor. But he's saying that's his role. But Mike's saying he knows Mike knows it too from working with other aircraft. But he says, well, Mike, just for the sake of role-based access, so we can sign this stuff off, can you be the worker? Not to say Elaine's not working with him. He's just saying those are the roles that they are assuming.
Yeah.
And then they bring in Kevin, who's QA.
Yeah.
Right? So in the computer system for maintenance, they'll all have different role-based access, where one can't go into the other's access privileges. They are locked out. So they can only do what they said they were going to do as far as signing stuff off in the system. Does that make sense? So that's an example of that. We know that honeypots and honeynets live probably in a screen subnet, or DMZ if you want to call it. They're the same thing. Okay? Sometimes
And if you
sometimes
change those settings,
your IT or your cyber division will want those folks to still be active. They notice something's going on, or they'll move them to a honeypot or a honeynet
inside the
and
DHCP server, you would
still allow them to hack, knowing that they'll never find the real door that leads to the inside of the network. Okay? If you've been watching The Matrix,
that will always be assigned to
who made it to part 2?
If you look at your
The freeway
DHCP
chase.
server, you might see this listed as static
You did?
DHCP assignment,
The key maker.
static DHCP, or an IP reservation. Here's the address
Public key, private keys. You notice how he got through back doors in the system? He said, oh, I think I got a key for that. PKI.
Yeah.
That's the key maker. He has the certs and all the keys to get in all the back doors of the Matrix. That's why he was so important. So the chase was the honey pot. They were chasing him through the network. They were trying to catch the key maker. They were trying to get the certs and the rights and the privileges. That's why they were trying to protect the key maker. The key maker was the certificate authority. The root. Y'all gotta watch it again. Y'all gotta watch. Y'all missed it. All right.
Yeah.
Those two twins, evil twins. Evil twins. Yeah. So you gotta go back and watch it. Yeah. All right. It can't be a coincidence. Yeah, it's all based off religion and IT merged together. All right. So if we look at it, you'll see risks, vulnerabilities, exploits, threats. Remember the CIA triad: confidentiality, integrity, and availability. You may get a question that posed to you. At which level will you
How are you
use
doing?
the appropriate?
This is class interaction, almost like an interview.
If I want to have
So
confidentiality,
it is video.
what can I use over here to
Video
assure
call?
confidentiality?
Or
That's
video
how you
class.
got to look at that question, okay? If I want to keep integrity of something, what can I use over here to keep integrity of it? And if I want availability, what can I use to ensure that all of it is available anytime I need it? That's how they'll pose the CIA triad to you in several questions, okay?
Yeah, it's virtual class.
And before we get out of here, we got 2 minutes. Audit to regulatory compliance, you'll see it here. Data locality, we call that sovereignty. Sovereignty, if you see it on the exam, means you would like to keep that data locally stored in that country.
Yeah.
Because that's what we agreed upon. Data sovereignty. I'd like to own it because I don't know what you're going to do with this data. All right? If we're looking at credit card industry, payment card industry will regulate that. It's not a law, it's an agreement. And then you'll have the actual law, which is the General Data Protection Regulation.
Where I am taking the class?
For the UE.
What do you mean?
Or the E,
Which website or which software?
For network segmentation, you'll see
I'm not
Internet
sure
of
what
Things
you're
being
referring
used.
to.
Internet of Things can be used in industrial Internet of Things. In anything industrial, you'll see a SCADA system that controls and keeps the data, and the ICS will regulate the system, okay? So pretty much these are isolated systems when you see SCADA and ICS. You want to make sure you have a guest network.
Okay, so all the
If you have a main
certificates
network,
are
and make sure
required
that they
through
authenticate
CompTIA
through
because
CAPTCHA. Remember
it's
that
one of
word?
the biggest
CAPTCHA.
worldwide certification.
You will see that on that one word on the exam.
Company, so it's all from CompTIA.
Especially for wireless access.
And we are doing
All right.
the video calls.
I believe in all y'all.
Through Zoom.
I believe in all. I think y'all got it. Y'all picked it up real quick from our last classes. I think y'all picked it up the quickest. Believe it or not. Yeah. So look at the babies. I love the babies. But Just get yourself a good night's sleep. Don't stay up all night trying to study this stuff, okay? My motto is, if it gets late and you don't know it, you don't know it. Get a good night's sleep. Get up in the morning, peruse something real quick, and just take the test. That's it. Relax. Yeah, get coffee before. Yeah, just relax before the test. All right. Trust what I'm trying to say. Trust what you know already. All right. Don't stay up all night, Mike. Don't stay up all night studying. Oh, she'll be up studying. You'll be asleep.
Yeah.
Any last questions before we get out of here? All right.
No.
Mike, I'll be waiting for that. Mike says, can you take the test as me? Give me the hat. Maybe I'll pass for you. I don't know. You got to give me a plane ticket to get out here.
Yeah.
All right. If you need something, I'll check my email every once in a while or my text. Just hit me up. All right? Don't forget to clock out, everybody. See you in the morning.
So the course that I'm doing, it's an expedited version of the standard version. So it's a minimum of 3 months, pretty much. So it's based on the certifications that you're trying to get, and I'm currently doing A+, Net Plus, Security Plus, and CYSA. And what is also included with that is the mastery course as well. So it all depends on what certificates you're trying to get. So just those four certifications alone guarantees a variety of job in IT. So it could be a data analyst or a security analyst, cybersecurity. It's an entire variety of jobs that you can use those security to get jobs with. Obviously, there's an entire long list of jobs, job listing that I can give you, but the basic minimums are just about anything that falls on the IT.
IPv4, and we've updated them for the modern network. Of course, there's DHCP for IP version 6. Those DHCP servers use a very similar process to what we saw with IPv4 to assign IP addresses with IP version 6. This uses redundant DHCP servers, so it's ready for the enterprise, and you as the DHCP administrator will be managing this DHCP version 6 server as well. But unlike IP version 4, IP version 6 can assign an IP address to itself and be able to communicate with anyone on the network. We refer to this as stateless addressing. There's no DHCP server that manages the process. You don't have to keep track of IP addresses or MAC addresses. And with this stateless addressing, there's no lease time, so you never have to worry about giving up your IP address. An important protocol that's used for IPv6 stateless addressing and other purposes is the NDP protocol. This stands for Neighbor Discovery Protocol. In IP version 4, we use the Address Resolution Protocol, or ARP, to be able to find other devices on the network. But ARP requires broadcasts to be able to operate. With NDP, we're using multicast, so the overall communication is much more efficient. The way that an IPv6
What questions are you asking?
assign itself an IPv6 address is using stateless address auto configuration.
Are you still referring to your previous message that that you just put in the chat? I'm not sure if you got my response to that. Is that what you're asking about?
It could potentially conflict with an existing IP address on the network. But in IP version 6, we have duplicate address detection, or DAD, and it checks to be sure that there are no duplicate IP addresses on the network. Neighbor Discovery Protocol can do more than simply find other devices on your network, can also identify routers using the router solicitation and router advertisement features. If a device wants to find a router that's on its local subnet, it uses this Neighbor Discovery Protocol and uses the router solicitation feature and sends that to a multicast that says if there's any router out.
So no, I am just initially getting the certification to enter into the IT field. Anything that I do now concerning IT is not what I do officially as a career. But I'm now just getting all the certifications to enter into the IT field. So I'm very much a beginner.
Might be interested in knowing where routers exist. This router advertisement is useful because it can provide information about the local subnet. Things such as prefix values, prefix lengths, DNS server.
Is that something that you're currently familiar with, or is that a career field that you're in?
So here's how Slack, or the stateless address auto configuration, works with IP version 6. The first thing your device does is determine what local subnet am I on, and it does that by using the Neighbor Discovery Protocol and asking a router through the router solicitation feature, what subnet is this? The router will respond back with a router advertisement containing that information. For example, we can query the router using this Neighbor Discovery Protocol, and we'll receive back this 64-bit IPv6 subnet prefix. You can see an example of that is listed here. But of course, that's only half of the IPv6 address. We also need what's known as the last 64 bits, or the interface ID. Many devices will take a modified version of their MAC address, put the letters FFFE in the middle to create 64 bits that it can then use as the last part of the address. Other devices will simply randomize this value to create those last 64 bits. And just to make sure that this random value, or the value associated with the MAC address, doesn't somehow already match an IPv6 address on the network, the Neighbor Discovery Protocol is used again. It uses a feature called Duplicate Address Detection, or DAD, and checks the rest of the network to be sure that someone else is using that.
If you're still in between, and so it depends on where you're at currently. If you have the time to do the classes and get the certification, if you have the time that you can put some effort into that, it's very rewarding. So it is a good pick. Just about getting one or two of these certificates will push you into a good field. IT is a good career choice, and it pays very well. Very much six-figure with 1 to 2 certificates. In this course, you're pretty much getting 4. And just with the certificates alone, that also includes, or it count as 9 to 12 months of experience. So it would very much depending upon where you want to go or where you're at currently, if you have the time to put the effort into it. Also, you don't necessarily have to go to a school to get these certifications. You can simply go to the CompTIA website, take the practice exam from there, because they have all the information that you need to be able to pass and get the certification. So you can simply go to the website, self-study on your own. You also don't have to pay for any material, because all the information that you need, they provide it to you with practice tests. Or you can go on YouTube. You have classes that shows you everything. It'll just be what you have to put the effort and retain the information that you're being taught. But it takes some time and effort.
One of the most common uses of DNS,
And the certifications are recognized worldwide, so you can use it just about anywhere in the world.
addresses that can be used to connect with
And you can even work with the certifications remotely as well.
www.professormesser.com. There's no IP address associated with that name. There needs to be some process to resolve the IP address based on that name, and we rely on DNS to provide us with that name resolution. This database of names is a hierarchy, and in this video we will look at the structure of a DNS database. We often describe this resolution process as one device that is receiving information from one DNS server. But in reality, there are many DNS servers. In fact, the root DNS servers consist of 13 separate server clusters that make up over 1,000 actual DNS servers. These DNS servers manage the top-level domains, or TLDs, of a number of different generic top levels, such as .com, .org, .net, and others. There are also country-level TLDs. Those are country codes such as .us for the United States, .ca for Canada, .uk for the United Kingdom, and so on. Here's an example of a DNS hierarchy. This starts at the very top of the tree, which is a single period or dot. Underneath that is the top-level domains, such as .com, .net, and others. And then you can have other names underneath those, such as Professor Messer. For example, you could have www.professormesser.com, all found by following this hierarchy. We refer to this as a fully qualified domain name, or an FQDN. You can structure the names used in your organization into this FQDN model. For example, you can start with professormesser.com, which incorporates everything within our domain. Underneath that name, you might have www.professormesser.com, which is the fully qualified domain name of our web server. You can continue to add on to this domain name. For example, in our organization, there is an east and a west for the domain names. And within the east, there might be servers and services with names associated with them. And in the west, there might be a separate group of services in that particular area of the domain. We use DNS to resolve the IP address of many different services. For example, a web server would be a very common resolution, but we also use this for things such as Active Directory and for application access. To be able to maintain uptime and availability of such an important service, we will often use redundant DNS servers. This means we might have 2 or more DNS servers, and we can configure our systems to use those redundant servers so that if the first server is not available, you still have another server to choose. You'll notice if you look at the configuration of your computer, there are usually 2 DNS configuration settings. This first one is for the primary DNS server. This is a DNS server that has all of the zone information for your particular DNS domain. Any changes you make to the configuration or updates to the config all happen in this primary DNS server. The secondary DNS server is not used for primary configuration changes. Instead, it receives an update from the primary DNS server. All of the zone information is pushed down to the secondary server in a read-only mode. And anything that we get from a secondary DNS server was first configured on the primary DNS server.
At the CPD, partnership is the cornerstone of success.
From the end user's perspective, of course, it doesn't matter which DNS server is referenced, the same information exists in both of those, and regardless of which server was accessed, the end user has no idea if it came from a primary DNS server or a secondary DNS server. In some situations, you might not want to query a named server to provide that name resolution. Instead, you might want all of that resolution to occur on your local machine. We refer to that as a local name resolution. For example, if you have a test server, you might want to configure your system to access this test IP address for that server rather than accessing the production server itself. You might also use local name resolution if you feel that the DNS server has incorrect information and you want to have your own resolution that corrects that information on your local machine. To accomplish this, we need a file with all of this name resolution inside of it, and the file name is commonly called the hosts file because the name of the file itself is called hosts. This is an example of the host database. It's simply a text file that contains information about the IP addresses and the names of the devices that you would like to resolve. For example, I have a test server for www.professormesser.com. Its IP address is 10.1.10.170, and I can configure my host file to access that IP address every time I reference www.professormesser.com. This works for many applications, but there are certain apps that will not reference the host file. Instead, they will rely on the DNS server as the primary source of information. So you'll want to check the documentation for your application or your browser to see how it resolves this information, and that way you'll know whether the host file is something that can be used on your system or whether you'll need to configure all of those settings on the DNS server itself. Here's a bigger view of this host file inside of Windows. This file itself is located at Windows/system32/drivers/etc/hosts. This is a file that is often stored as a read-only document. So if you want to make changes to this file, you'll have to first change the file so that you have read-write access. And once you do that, you can modify the text within this file to have the IP addresses and names that you would prefer rather than the ones that are located on a DNS server. One of the most common uses of a DNS server is to provide a forward lookup. This means that we provide the DNS server with a name and it returns with an IP address. For example, we can send the name www.professormesser.com to the DNS server.